Hi everyone, I'm Bowen Zhang from USTC. I'm excited to share our work MetaPortrait Identity-Preserving Talking Head Generation with Fast Personalized Adaptation, which has been accepted by CVPR 2023. This is a joint work between USTC, HKUST, and Microsoft. Firstly, let me briefly introduce the task of talking head generation. Given an image of a person, which we refer to as the source image, and a driving video, which is used to animate the source frame, our goal is to generate the output results with the motions from the driving video while maintaining the identity of the source image. Talking head generation has found extensive needs in avatar creation for both movie industry and virtual reality. For instance, in the movie Avatar, researchers used professional equipment to capture the actors' facial expressions, which was then used to guide the virtual avatar synthesis. In the metaverse or virtual reality, each person needs their own avatar to communicate with each other. All of these techniques heavily rely on talking head generation. We observe that previous works mainly had the following shortcomings. They try to learn the geometry of a warping field by interpolating from sparse 2D landmarks or 3D frames prior, which fails to well model fine-grained facial geometry. Also, the identity of the source image suffers from severe loss, especially when performing cross-identity rearrangement, resulting in poor user experience. In order to obtain high-quality generation results when animating a one-shot in the wild portrait, we propose a carefully designed framework. Given a source image and a driving video, we first extract and encode their dense landmarks, then estimate the warping fields. We further refine the warped source input using an identity-preserving network. Finally, we utilize a temporal super-resolution network to obtain high-fidelity results. Okay, I will introduce each part in detail. We propose to use dense landmarks in warping prediction to obtain a geometry-aware warping fields. While dense facial landmarks are hard to label, our landmark prediction network is trained on synthetic faces, which provides 669 facial points covering the entire head, contains rich information about the person's facial geometry. After obtaining these dense landmarks, we propose to draw the neighboring connected landmark points with color lines, efficiently converting the input landmarks into a 3-channel RGB image. Next, we take the source image and landmark images of source and driving as input of the warping network. Our warping network predicts the flow fields in a self-modulation manner. A latent code Z is first derived from the input and then injected into the flow estimation network. Ablation shows that our warping network with dense landmarks can effectively provide high-quality warping results. Then we warp the source image with the predicted flow field. In order to produce photorealistic results while maintaining the source identity, we propose an identity-preserving network to further refine the warped source image. Inspired by recent face warping approaches, we are supposed to explicitly consider the source identity during refinement. We utilize a pre-trained face recognition model to extract the source identity feature. The refinement network attentionally fills the driving motions and source identity features in a spatial adaptive manner. Ablation study demonstrates that the proposed method could significantly improve the identity-preserving capability. We further propose a temporal consistent super-resolution network to enhance the generation resolution and improve the high-fidelity details of output while ensuring the temporal coherency. We leverage the pre-trained style GAN, which contains rich facial prior to enhance the high-frequency details. To be more specific, we concat T video frames into a 3D UNet and use the spatial temporally enhanced features to modulate the pre-trained style GAN to produce the final output. Experiments show that we could achieve temporally coherent results with high-fidelity details with the help of the proposed temporal super-resolution network. Here are the visual comparisons with state-of-the-art methods. From the self-reconstruction video, we could observe that our model provides more accurate and fine-detailed synthesis on gaze, mouth, and expressions. The results of cross-identity rearrangement show that our method is the only one that well preserves the source identity, demonstrates the effectiveness of the proposed method. While our one-shot talking head generation model has achieved state-of-the-art quality, we encounter the uncanny valley that a user becomes uncomfortable as generation results approach to realism. This is because one-shot setting is inherently ill-posed. For example, one may never hallucinate the person-specific occluded parts from a single photo. To overcome uncanny valley, one commonly used method is to fine-tune the model using several minutes of personal video. Such personalized training has been widely adopted in industry, yet this process is computationally expensive, which greatly limits its use scenario. We propose to achieve fast personalization with meta-learning. The key idea is to find an initialization model that can be easily adapted to the given identity with limited training iterations. Our meta-learning model explicitly considers the personalized adaptation during training and implemented based on Reptile, a first-order mammal-based approach. Such meta-learning initialization allows us to train a personal model within 30 seconds, which is 3 times faster than a vanilla pre-trained model. Here are the generated results of Obama using the one-shot model before personalization. It is hard for the model to synthesize person-specific details and occluded parts on the one-shot setting. We could easily obtain Obama's personal model after 30 seconds of personalized adaptation based on our meta-learned initialization. The personal model of Obama is able to generate high-quality results with rich person-specific characteristics. Thanks all my collaborators. Our code and model are available on GitHub. Thanks for your watching.